Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2183, indicates an issue with the Engine Coolant Temperature ECT Sensor 2 circuit, specifying a range or performance problem. This can result in improper engine temperature readings, which may lead to suboptimal engine performance and fuel efficiency. The ECT sensor is crucial for relaying the engine's temperature to the Engine Control Module, ECM, or Powertrain Control Module, PCM, facilitating appropriate fuel and timing adjustments for efficient engine operation. It's typically located near the engine block or cylinder head, where it can accurately measure the coolant temperature. Given that multiple components interact within this system, careful diagnostic procedures must be adhered to for accurate repair. Before tackling this issue, it's essential to document any freeze data and onboard snapshots to allow for a comprehensive understanding of the conditions leading to the DTC. The Engine Coolant Temperature, ECT Sensor 2, plays a pivotal role in determining the engine's operating temperature. By measuring the temperature of the engine coolant, it helps in optimizing fuel injection and ignition timing. This sensor is commonly situated on the engine block, making it strategically positioned to acquire accurate temperature readings. A malfunction in this component can lead to incorrect data being sent to the ECM, affecting overall vehicle performance and efficiency. Identifying the specific location of the ECT sensor is critical during diagnostics, as it directly impacts the cooling and heating cycle of the engine. Additionally, any disconnection or electrical issues may introduce further complications in this system, necessitating a thorough inspection of connections and terminals to guarantee reliable operation. When examining the possible causes of DTC P2183, three main issues are frequently identified. First, a faulty ECT Sensor 2 can provide inaccurate readings, triggering the DTC. Sensors can become defective due to wear and tear or exposure to extreme temperatures. Second, poor connections, including loose terminals or corroded wiring at ECT Sensor 1 or ECT Sensor 2, can lead to communication failures between the sensor and the ECM. Finally, issues with the ECM or PCM itself could prevent accurate signal processing or response to the data received from the sensors. Each of these causes could contribute to the overall performance problem indicated by the DTC, making it essential for technicians to investigate systematically. Different possibilities emphasize the complexity of the system and underline the importance of a careful approach to troubleshooting. Recognizing symptoms associated with DTC P2183 is vital for effective diagnostics and repair. Drivers may notice poor engine performance as the ECM struggles to adjust fuel-to-air ratio and ignition timing without reliable temperature data. This reduced performance can be particularly apparent during acceleration. Additionally, drivers may experience decreased fuel efficiency due to the engine operating outside its optimal temperature range. This inefficiency brings about increased fuel consumption and higher emissions. The vehicle's dashboard may also display a check engine light, alerting the driver to issues requiring immediate attention. By understanding these symptoms, technicians can narrow down their focus during diagnostics and address the most pertinent issues. Awareness of patient symptoms not only aids in troubleshooting, but also enhances driver safety and long-term vehicle reliability. The first step in troubleshooting DTC P2183 involves examining the connections and terminals at ECT Sensor 1 and ECT Sensor 2. Poor connections or loose terminals can prevent accurate readings from the sensors, potentially triggering the Diagnostic Trouble Code. It's crucial to inspect these connections visually for any signs of corrosion, fraying wires, or physical detachment from the sensors. If you ascertain that the connections and terminals are functioning well and securely connected, you would proceed to the next troubleshooting step. However, if issues are detected, such as loose or damaged wiring, appropriate repairs should be made to ensure a solid connection. This step emphasizes the foundational nature of proper connections in automotive electrical systems, as inconsistencies can lead to a cascade of faults affecting performance. In the second step of troubleshooting, the ignition switch should be turned to the on position. 2. Preparatory for diagnostic scanning. Using the Honda Diagnostic System, HDS, technicians should check for any pending or confirmed Diagnostic Trouble Codes, DTCs, present. It's essential to confirm whether DTC P2183 is indicated alongside P2183, since dealing with P1116 first is a prerequisite for accurate diagnostics. If both codes appear, they share a potential common issue that warrants immediate attention. If P1116 is absent, the process can then advance to the following step in the diagnostic procedure. Utilizing the HDS for this check is vital, as it provides real-time data and helps in pinpointing the issues affecting the ECT system. This step involves starting the engine and allowing it to idle for a continuous period of 10 minutes. This idling time is critical, as it allows the engine to reach a stable operating temperature, reflecting real-world driving conditions. During this idling phase, the ECT Sensor 2 should begin to provide data that will be used in the next diagnostic steps. It's important that the technician monitors the temperature readings closely, as they are central to assessing whether the sensor is operating within an acceptable range. Ensuring that the engine has adequate time to warm up mitigates the chances of misdiagnosis caused by fluctuating temperatures. Successful completion of this step paves the way for deeper analysis of sensor readings using specialized diagnostic tools. Following the 10-minute idling period, the focus shifts to checking the readings from ECT Sensor 2 using the HDS. It is imperative that the ECT Sensor 2 indicates a temperature of about 120 degrees Fahrenheit or 49 degrees Celsius or lower for standard operations. When the readings are above this temperature, it raises concerns about the function of the sensor. It is an indication that the ECT Sensor 2 might be malfunctioning. This check is crucial, as it provides a direct evaluation of sensor performance. If the temperature exceeds this threshold, the logical next step is to replace the sensor, thus addressing the root of the range performance problem indicated by DTC P2183. Conducting this step with precision ensures that the vehicle can resume optimal operational standards. This step entails turning the ignition switch to the lock position 0 and allowing ECT Sensor 2 to cool to ambient temperature. By letting the sensor cool, it becomes possible to evaluate whether it accurately reflects the temperature of its surroundings, which is crucial to verifying its functionality. During this cooling period, the ambient temperature should be recorded, serving as a baseline for comparison in later steps. This process is critical in diagnosing issues with temperature reporting, as failing components may distort measurements once the sensor is no longer at a stable temperature. Thoroughness in this step decreases the risk of overlooking symptoms of intermittent faults that could complicate diagnostics. After allowing adequate cooling time for ECT Sensor 2, the next action is to set the ignition switch to the on position 2. Technicians should then monitor the ECT Sensor 2 value using the HDS once again. The essential aspect of this step is to compare the value observed with the previously recorded ambient temperature. A difference of 5.4 degrees Fahrenheit, 3 degrees Celsius or more from the ambient temperature indicates a malfunctioning ECT Sensor 2, necessitating replacement. If the readings are within this threshold, it may suggest an intermittent failure, suggesting that sensor performance is fluctuating. In either case, the importance of accurate and reliable readings cannot be understated, as they provide vital data for the ECM's functioning. This stage of diagnostics focuses extensively on pinpointing faults in the sensor's output, ensuring that subsequent steps remain grounded in data-driven assessments. The final repair verification process includes critical steps to ensure successful resolution of the issue indicated by DTC P2183. Initially, any defective components, such as the ECT sensor 2, should be replaced before proceeding to the next verification step. After replacing components, technicians must use the HDS to recheck for any returning DTCs, confirming whether the problem has been rectified or if further diagnosis is required. It is also important to verify general system functionality. This encompasses monitoring the engine's operating temperature and performance during regular driving conditions. Conducting tests allowing the vehicle to operate under various conditions will further validate the integrity of the recent repairs. This comprehensive approach reinforces the quality assurance of the diagnostic and repair processes undertaken previously. Preventive maintenance surrounding the ECT sensors is essential for ensuring the vehicle's operational effectiveness and longevity. Regular checks of the ECT sensors not only facilitate early identification of potential issues, but also preserve the integrity of the sensor readings. Technicians should conduct visual inspections of the connections leading to both ECT sensor 1 and ECT sensor 2 periodically, looking for signs of corrosion, wear, or any form of detachment. Additionally, maintaining optimal engine coolant levels can help regulate temperatures within a safe range, subsequently extending the lifespan of the sensors. Preventive maintenance is about being proactive rather than reactive, thereby minimizing the risk of disruptive breakdowns associated with engine temperature regulation failures. Implementing these practices fosters a dependable vehicle performance landscape that is both efficient and effective. In conclusion, understanding the critical role of the engine coolant temperature (ECT) sensor, particularly sensor 2, is vital in addressing DTC P2183 efficiently. A systematic approach to troubleshooting, starting from checking connections to verifying sensor functionality, ensures issues are identified accurately and rectified effectively. The emphasis on regular preventive maintenance practices, such as routine inspections and coolant level checks, can greatly reduce the chances of encountering similar issues again in the future. By fostering a comprehensive understanding and proactive maintenance culture, vehicle owners can enhance their Honda Accord's performance and longevity. Emphasizing knowledge and methodical procedures empowers both technicians and vehicle owners to tackle complex vehicle issues with confidence, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.